Okay, hi everybody. At this stage, I'm just going to show you how the pewtercaster works. So, in order to use the pewtercaster, first off, you'll need a visor to protect your face. It does say low temperature casting system on the machine, but the low temperature is still very high temperature. It's the metal melts at about 250 degrees C, which is about your oven at its hottest. Now, obviously, if for whatever reason the metal splashed because it's molten liquid metal, it could obviously splash and then go on your face and your eyes or anything. So obviously you want to cover your entire face to make sure that none of your face gets burnt. You also need leather gloves. Now leather is a lot thicker material, so the metal can't get through the leather. So if metal drops on or splashes onto the leather gloves, then it won't affect it. It will just roll off. And same thing here, we've got a leather apron, so for exactly the same reason. In industry, they would wear leather leggings as well, which basically is just a leather cover for your legs to protect your legs. But in this situation, it's very low risk, so you're just going to use a regular, just use your regular trousers, should be fine for that. You also need leather shoes. Again, if anything spills on your shoes, you don't want the metal to be able to go through your shoes. And you've just got to be really careful around this machine. This top bit is obviously the lid. Now this is where you put the metal into. Now if metal goes into that section, it melts and it comes out of this part here, out of this little funnel here. Okay. Now if any water gets into this top section when the metal is being heated up and turned into liquid, then it reacts violently. So you've got to make sure no water goes near that top section. And obviously you've got to be very careful around the machine. You'll also find a white line around the machine to say stay out of this section, just in case the metal splashes or anything when someone's using it and you're not protected. Obviously you've got to make sure that you are. So all people who aren't using the machine and haven't got all the safety gear on needs to make sure that they are protected and not inside that parameter. Okay, now if you have a look at the mold here, what I've got is, just rewind it back a little bit. So there's three sections. There's the section that's open, which your metal's going to pour into with a funnel just there. You got the piece which has got the engraving on, which is going to have to be lined up with the gap. And then I've got a blanking piece that stops the metal from coming out in the other direction. So when I line these up, let's make sure that they're perfectly lined up with each other so that you can see the engraving is clear. And then hold it tightly together. And then I'm going to use masking tape. It's got to be masking tape. Well, it can be, you can clamp it together just with small clamps. But the problem with the small clamps is they struggle to get into the gap. So if you tightly wrap masking tape around about 2 or 3 times, it should hold it, but it does hold it in place well enough that it will hold the pieces tightly together. Now it's important that you double check your mold that there are no gaps between the pieces of wood, because if there's any gaps, the metal will pour through. So you've just got to make sure it's really tightly masking tape together. So you go around a couple of times, but really try to do it nice and tight so it doesn't come through the gap. Don't use sellotape, because sellotape will melt when it gets very hot, so it could then come apart easily. So it has to be masking tape, because the paper doesn't struggle as much with the heat and it won't come apart. Okay. Now the next stage is, obviously you can see me putting on my safety gear, leather gloves, and the mask. Now you'll notice one other thing, there's loads of splash marks around the outside, and sometimes it drips out. It's not particularly very good designed system in some ways, because the little stopper that blocks the metal from coming out does sometimes get blocked and it drips out, and you can see it splashes sometimes onto the side. So that's another reason why you've got to be very careful around it in case it splashes and burns you. Now at this stage, there's a little handle just here on the right hand side. Now when I pull that handle down, it works like a lever. When you pull that down, it then lifts up like a plug inside here. So pull down and it levers up this section and lets the metal pour out. And you can see, if I pull that lever, you can see it dripping out. When it gets full, you'll see me tapping it gently on the side, and that removes any air bubbles that you might get into it. Now, what happens sometimes is the metal ends up dropping down because you've had air bubbles inside it, and because the air bubbles have now gone, the metal can get into those gaps. And when that happens, you then need to put a little bit more metal into it. Tapping it for a while just to make sure all air bubbles are out. And then just fill it up a little bit more if needed, and then just tap again to make sure that it's all full. Next thing to do is I'm just going to leave it somewhere for it to set. Now, it usually sets within a minute, so it sets solid within a minute. Or the longer you leave it, the better. It gives time for the molecules to align, and it makes a much stronger metal keyring. But a couple of minutes is probably enough. Now, after a couple of minutes, it's still going to be very, very hot. So you will need to still make sure that you're very careful around it because the metal will get very hot. Okay, thank you for watching that stage. Okay, hi everybody. At this stage, I'm going to show you how to cut off the funnel. So obviously you can see that that's the mold that I need to take apart in a second. And show the keyring. I'm going to use one of these tools. It's called an engineer's vice, and you find it really useful for holding the metal in place when I'm working on it. I'm going to clamp down the engineer's vice to the table with a G clamp so it can't move around when I'm working on it. I'm going to use a junior hacksaw just here and a pencil to mark out where my funnel's going to be marked. I've also got a pot of water away from the pewter caster, so no water goes near the pewter caster. Otherwise, it reacts violently with the temperature difference, and the metal will spit. So you've got to make sure that you're away from any liquid metal when using water. But if the metal's hot still, and I haven't waited very long, I can then cool it down faster in the water. So I'm going to use a bit of water on that bit. So you'll see at this stage, I'm going to carefully take it apart now. You'll notice that my hand positions, I've got a thumb there and my finger there, and I'm very careful not to touch this bit, all the metal, because it can still be very hot. So because wood is an insulator, the edges won't be that hot. It doesn't conduct heat very well, whereas the metal will be very hot. The wood will probably be hot at this point and on the back, so try not to touch those bits, just on the edges of the wood, and it'll mean that you don't burn your fingers. So just be careful not to drop it like that. Now you'll see, you just carefully prise it apart, and there's the mold. Now try and get your finger into there, your thumb into there, with your nail, and just break that apart. And you can see the design has then hopefully stayed on it. I just dropped the design into the water just to cool it down. Now, I'm then going to break the mold. Now, if you can get it out gently, you might be able to reuse the mold again once the wood dries. Or if you'd waited long, you might not have needed the water at all, and you could carefully take it out of the mold, and you could have reused the mold. And that's called batch production if you manage to use it quite a few times. At the moment, because I've broken the mold after the first time, that's called one-off production. Okay. Now, at this stage, I'm going to draw with my pencil where I want to cut off the funnel. Okay. I'm going to very carefully just draw along that line so you can see it. And then I'm going to set up the engineer's vice to the table, clamp it down nice and tight. I'm going to put it so I'll be sawing downhill, so downwards. So you can see I put it at an angle so the funnel is at the side, and I'm going to be sawing down. It's just a lot easier to see what you're doing, and it's a lot easier to saw down. Now you've got to be very careful when you use the saw that you saw on the waste side of the line. Now the waste side in this case is the funnel. So I don't want to be sawing perfectly on the line, because if I do, I could end up sawing off a bit of the keyring that I want to keep. So if I saw touching the line but on the waste side of it, then it won't damage my design, and I can file it back if I need to take a bit more off afterwards. But if you saw on the line, you can easily go over the line and damage your work. But also, the saw blade has a thickness, and whenever you saw, you end up removing a section that you saw. Okay, so be very careful when doing that. And then saw down very carefully, keep it nice and straight, don't have the saw at an angle, and just slowly cut through. Now, that's ready then to file down, and you can see there's a little bit of extra funnel there that can go back into the pewter caster to be melted down afterwards. You just give that back to teacher, and then he can put it back so that it can be recycled. Okay, and there it is. Okay, thank you for watching. Okay, so at this stage, I'm going to show you how to file down the sides, the edges of the metal. Now, to start with, you're going to need a needle file, although you can use a regular flat file, a bigger flat file if it's a bigger section that you're filing down. The needle file is just useful for smaller sections and getting into little gaps. So you can choose whichever file is most suitable for your design. I'm going to use a 50 grit sandpaper, which is really rough, little chunky bits of sand on it. Which will be used to get rid of the really rough sections after you've filed it. Then I'm going to use a 100 grit sandpaper, which is like a medium rough, still quite chunky piece of sandpaper, but it's a little bit smoother, and it'll bring down the scratches even more from the rough. So you'll have the rough sandpaper, which will still leave quite a big chunky scratches on. I'm going to use the 100 grit sandpaper, and then the 150 grit sandpaper, which is much smoother sandpaper. And if you've got anything higher, like a 200 or a 300 wet and dry paper, then you can obviously smooth down even further. But at least 3 different types, a rough, a medium, and a smooth will be useful. And then a bit of wire wool will help smooth this out afterwards as well. Now, ideally, these would be emery cloth instead of sandpaper. Emery cloth is a bit more useful because it just protects your fingers a bit more instead of the metal slicing potentially through the paper. An emery cloth will protect you a little bit more from the cloth instead of the paper on the back. Will protect your fingers better from any rough bits of metal. But this is a fairly soft metal, and it doesn't seem to make too much difference. And especially if I wrap the sandpaper around a file, I do find that it works just as well. Now, first off, I'm going to reposition the engineer's vise into a more useful position. So you can just twist it at 90 degrees and then reclamp it down. Make sure it's nice and clamped so it doesn't move around. Now, I'm then going to position the key ring. Let's rewind it a little bit just so you can see that. So you can see it position it so it's edge on, so I can see the edge clearly, ready for filing it down. Make sure it's clamped up nice and tight. You can protect the metal. If you're worried about the metal scratching, then 2 little pieces of wood on either side, scrap pieces of wood on either side, will protect the metal better and make sure it doesn't scratch it. Because it's already messy on this face and on the back anyway, I'm not too fussed at the minute. And I'm going to be filing that down anyway, so I'm not too worried about the metal engineer's vise scratching the key ring at the moment, as long as it's careful. Okay, so there's 2 different filing techniques. This one's called cross filing. You put your hand on one side, hand on the other, and you go across the metal at 45 degrees, back and forth across it, and up and down at the same time. So you can see, you go across it. So work on one section at a time, no more than about 4 or 5 centimeters. Should be fine. So up and down at 45 degrees across the metal. Now this removes the larger sections, any really rough sections with the cross filing technique. So it's the first one to use because it removes the roughest sections of the metal. I'm then going to do what's called the draw filing technique, where you put it at 90 degrees across and you hold it in both hands and you go back and forth, and that just smooths it out a little bit. So it smooths it across. So just back and forth at 90 degrees, and it just helps to level it a little bit more. Okay. Now, the next thing we're going to do is I'm taking the 50. I do know it says 93 on the back of there, but it's the numbers don't seem to correlate with the texture, so I think it's around about 50. And what I'm going to do is I'm going to wrap the file around the sandpaper around the file. I'm going to do draw filing technique, so you can see. And what you'll find is with the sandpaper is the sand comes off very quickly, so you need to keep rotating the sandpaper to make sure that you are actually sanding with sandpaper and not just paper. Okay, so you do need to keep rotating it until you get a fresh piece. Okay, the benefit of emery cloth would be it probably would stay on a bit better as well than the paper, but it does the job. Then I moved on to the 100 and repeat the same process back and forth. Draw filing technique with the 100, and hopefully each time I'm making the scratches smaller and smaller. And again, rotate the sandpaper and use the whole across the whole section, not just the middle of the sandpaper. Try and use it all. So you can see I'm moving back and forth and across to make sure that I'm using all of the sandpaper, and I'm also rotating the sandpaper around. Now move on to the 150 and repeat. Again, now the scratches should be very small. The idea being that you're trying to get rid of all scratches, so there is no scratches anymore on it at all. Okay. So you're making the scratches so small that you can't see them anymore. And then the wire wool should just really shine it up. It basically just cleans the surface of the metal and gives it a really nice shiny finish. Really useful to get rid of any marks. But the wire wool won't work very well unless you go through the stages of the sandpaper at all times. And you should be able to see a nice shiny finish, ready for then the next stage. Okay, thank you for watching.